Hello class, we're going to go ahead and jump right into chapter 3. Before I do so, if you have any questions over the test, I know that was an unorthodox on-Canvas type test, or you need me to unlock it, or you'd like to retake it, or you haven't taken it yet and you need to, please do that now. I can understand late penalties, but I can't understand if you're just not doing it. As we've seen in chapters 1 and 2 already, we can assign probabilities to pretty complicated situations. We've used trees, event blanks, counting techniques, and we can reevaluate those complicated situations by just simply calling them event E. And you'll see a lot of these E's throughout as we talk about our definitions. An axiom is something in mathematics that is just kind of a given. It doesn't have necessarily a definition. It just is what it is for the structure of the definition, I guess, another definition. So like for instance, the definition of probability is that it's some decimal between 0 and 1. We know that. The probability of S, which means that something happening in our sample space, is 1 because, well, we use this all the time when I call this the certainty equation. Certainty meaning 100% going to happen. We'll use an equation like W1 plus W2 plus W3 equals 1. We've seen that before. So the last part here that I've highlighted, it says if E1 and E2 are disjoint, which means they share nothing, then if I were to say what's the probability of this or this happening, we would just add those two together, and that's just a given. Probability of an event, we don't really need to go too deep into the second box, but it says for any event E cannot be the empty set, which means an event is not an event if nothing occurs. So the probability of the empty set is 0. We know both of these. I think that's self-explanatory. And then the last thing, it says for an event E, not E, is 1 minus the probability of E. So we already know this as a complement. So like if there's a 30% chance of something happening, there is a 1 minus 30%, 70% chance of it not happening. So we sort of already knew this. I just wanted to re-highlight it for you. Number 2, for any collection of pairwise disjoint events, so any events that have nothing in common, we can just add those together like we could up in box 1 right here. And 3, for any events E and F, if they do share anything, we would still add, but we would take out what it is that they share. So if you think of how E and F are predisposed, E and F is going to be that shared region there. Reforming these questions back into Venn diagrams is going to be a focus for this section. So number 1 kind of just gets you reacquainted with what we did in chapter 1. It says let A and B be events in the sample space S. Let the probability of A be 55, but remember there's going to be some overlap here. So let's say this is A, this is B. It says A is 55, but we don't know what's here in the middle. Same here. But then it goes on to tell us 0.2. Okay, remember, put that in there first. Because if you go ahead and label 55 here at the beginning, now you have 75. That's 0.2 plus 0.55. That's 75 in A. You have 20 too much. So remember to always subtract that out. Back. So if I take 0.55 minus the 0.2, that leaves me with 0.35. And I'll do the same thing with B, 0.35 minus, and again, it's that same overlapped region. All right, so you've got all your pieces accounted for except for the margin. And so if we think, okay, 35 plus 20 plus 15, what does that give me? That's going to be 70. So I need an additional 30, or you could say 1 minus 0.70 to give me the outside. Okay, so 0.3 is our margin. Once you have your picture, go to your question, and I would make little sketches that match my picture and grab the numbers that I need. So for instance, it says the probability of not B and A. Shortcut for this is to understand that this means only A, so that would be this region here. But if you were doing this without the shortcut, how might you do that? Well, not B would be anything out here, right? Anything but that circle on the right. And then if I were to do A, I'd have a little bit there, but not enough overlap in the middle, just to the left. So that'll be this 0.35. Okay, just matching my picture with the numbers in my other picture. The next one is just vice versa. So this is saying only B. So only B is this other crescent. That's going to be 0.15. And if you want to mark that as only A, this pattern works every time. If the first one has a complement on it, meaning not, and the second one doesn't, the one that doesn't is the region of the only. So this one is only B. And the last one, I would use a rule we used to call De Morgan, which meant if I had a double negative, I can rewrite the problem as the opposite U symbol. So this is upside down, this is right side up, one negative on the outside. And what does that look like as a picture? Well, A or B would be the circles. So not, that would be my margin. Okay, so that's 3 quick rules, some shortcuts that we used in chapter 1. Let's expand that now into example 2. Now, number 2 has 3 circles, as I've already drawn on the right. And just a reminder again, no real shortcuts here, but always look for the big intersection of all 3. That's this region right here, and you want to label that first, because you're going to, and that's 0.05, not 0.5, and you're going to subtract that out of any region which it's a part of. It's a part of 3 regions here and 3 regions here, so you're going to subtract that number out quite a bit. So let's work our way backwards here. We've done this number. It says E and G. E and G. It's right here. By the time I'm done, this whole set of circles will be green. But it says it's 0.1. Now, we've already got 0.05 inside. So if I subtract that out, I'm left with another 0.05. To the next one, F and G, right here, is 0.25. But again, I'm sharing that 0.05, leaving me with 0.2. Let's see. Used this one, E and F. Let's see if we can do this one on our head. It says 0.15. I already have 5. That leaves me with 0.10. Okay, let's check that. 0.15 minus 0.05. 0.10, or 0.1 if you prefer. And we've used that one. G is supposed to be 70. So if I take the 0.7 that it's supposed to contain minus what's already inside, so that would be anything inside that bubble there, that's going to leave me with, let's see, that would be 1030.4. And you do that all the way around to get to this. I'm going to let you finish some of the picture, just make sure you're kind of interacting along. If you don't understand how I'm getting these numbers, make sure you send me a message. Part A says E and F, but they have complements, so that's the not region, and G. So that means only G. Notice how there's a negative, and then the positive one. So that's this region right here. Answer is 0.4. E or F or G, that utilizes our rule from up top, which means it's all the circles added together. So you could add together all of those 6 or 7 or 8 regions if you wish, but think of it this way. If you have all these circles and all these regions to add up, all these little regions, 0.07, 0.2, 0.05. Wouldn't it be easier just to say what's on the outside? I don't want that number. That's really the only number I'm excluding, right? So you can add up all those numbers, or you can do the complement and subtract. That's what we used to call in chapter 2 the quick way versus the long way. And then your last region here, draw kind of a bigger picture, better explanation. So E and F is here, along with G. Okay, so remember, or just means to tack it on, and is the one where we're talking about some kind of an overlap. So the regions we are leaving out here, it looks like, are those three numbers, right? So we could do 1 minus 0.06 minus 0.07 minus 0.07. Final answer would be 0.8. And I'm sure if you added together all these little regions in here, you would get the same answer. Now, example 3 is a little different. We're going to solve the questions A through C without exactly labeling every specific part, and still using pictures and shading. So, without reading too much into the details of the problem, we have E, F, and G, and, I see there's all these probabilities, but those aren't that important right now. What we want to kind of focus on is just the picture. So like on A, if I had 3 circles here, E, F, and G, and it said not E and F, well, wouldn't that mean only F? Only F, right? Because there's a negative and then only one positive. So if I do only F, okay, well, let's see if there's something like that up here. No, there's nothing that describes that, but here's what you can do. You can say, okay, well, I want F without that overlapped section that we usually call E and F. And so, well, the probability of F, that's right here. Take away E and F, which is right here. Answer is 0.3 or 0.30. On to the next one. Let's call this one A. I think my pictures are probably going to get a little scrambled, so I'll try to label best I can. So this will be the big picture for B, and we'll put C somewhere over here. For part B, I want to direct you back to the front page. If you can click back there just real quick, it says that anytime you have the probability of an or, E or F, just add them together and take away their overlap. So if we look at this one, and again, this is B, we're going to do F or G. So that would be here. E, F, G, right? And I'm just going to take another color, green, and highlight that we have some overlap here. And my probability should be F plus G minus the overlap. Okay, so using this probability formula, what I wind up with is probability of F they gave us to be 0.45 plus the probability of G, which they said is 0.55. So right there you're at 100%, minus the overlap, which was 10. So your final answer here is 90%. Again, that's because you're subtracting. Okay, and part C, last one, says not E or G. Okay, so just to not confuse, not E and G would be only G. Not E or G means something completely different. Not E would be everything out here, including the margin. Okay, so E is not shaded, but then we have to tack on G, which most of it we have shaded already, except this part, and this gets added onto it. So the equation you might use here is that we're saying, okay, I want not E with that shaded region that we just tacked on, which was E and G. Okay, well, let's see, not E. If E is 35, then not E is 0.65. Remember, any complement can give you the other guy. If you know 0.35, subtract that from 1. Okay, so this was E, this is not E. And then E and G was given as 0.12. Answer is 0.77. Go ahead and try day 1 of 3.1. The answer key is listed online, but you will have to show work to get credit. And I know this is really messy. Hopefully your notes look a lot better than my scribbles with my stylus marker, but if you have any questions, again, don't hesitate to ask. I know I've said that a million times, but I can't encourage you enough. And if you haven't finished the Canvas test, please email me about that as well. Thanks.